Hi. Today we are going to continue with the topic we were discussing in the C programming. So we had discussed the functions and we had discussed about recursive functions also. Now we will start with the call by value and call by reference method of passing parameters. Okay, so what is this call by value and call by reference? So we in functions, when we pass the parameters, there are two types of method. One is called call by value and another is called call by reference method. In call by value, we pass the copy of that variable, but in case of call by reference, we pass the address of that variable. So any changes made in this call by reference method will be reflected in the calling program, but the changes done in the call by value method, the changes done will not be reflected in the calling program. Inside the function that will be seen, but outside the function means we are calling, suppose in the main program we are calling that function changes done in that program will not be reflected after the function call of that when we are passing this value by call by value method. Okay, so let us see that what is it. Well, let us see what is the difference between them and then we'll see some examples. So in case of call by value method, the first one, we pass the copy of that variable inside the function. So we are actually creating a new variable, or you can say the new memory will be allocated to that variable which is passed. Okay, so that is why whenever we make changes inside the function in that variable which is passed using this method, that is passed by value or call by value, the changes done in that variable will be done only for that function only. That change will not be reflected in the calling program. And what is this calling program? Calling program is the main program where we call that function. Suppose your function is this one. Okay, have defined something, and there inside this function you have some parameter a, and you have some. Suppose when you are calling this in your main function, you are calling this function fun using this 3. So your a is 3, and now you are updating it by a plus 1. And then if you print this inside this, you will see the result. Okay, you will see the correct result here when you print it. But when you want to print the value outside it, suppose we have this variable integer b equal to 3. Okay, and then we pass this value b, and then we try to print it here. Percent d for b. So what you will find that when you print with this function b, it will print the value 4. But when you are printing this statement, it will print the value 3 only, because we are passing the copy of this variable. They're not this variable exactly. So when we create a new copy, it will be allocated a different memory space. So whenever we make any modifications inside this function using this method, that will not be reflected here. Okay, so that will not be reflected here. So to reflect the changes made in the function in the calling program, we have to use this call by reference method. In call by reference method, the address of that value passed, address of the variable is passed. And through this, we can, the modification we make is done in that memory location only. So whatever changes we make in that variable, it will be reflected in the program. So let us write some point or difference. You see what happened. The function, when we write the function definition, suppose your function is this fn, and inside this we write some argument. Okay, this is the function definition. We have some statements. Okay, but in the main program, where we call this, like suppose I write int b equal to some variable value 5, and then I am calling this function fn by passing b, or okay, so what happened, this is called the formal argument, which is in the definition. Okay, here it is named as int a, and here it is b. So this is called the actual argument, and this is called the formal argument. And this is actual argument. So in case of this call by value and call by reference method, we will tell you about this, what happens in the case of formal sorry, what happens in case of call by value method. When we create and call this function by pass by value or call by value method, a copy is created, means the copy of b is created, which is passed in a. So this variable gets another memory location. Here it is stored in b, which is allocated some space. B is allocated some space, and a will again be, when we are defining this function and when we are calling this function, this copy of b is assigned to a. So a will be assigned another memory location. Okay, this is in case of call by value method. So see the differences I have written here. Let us discuss all the points. So when we use call by value method, a copy of the value is passed into the function. But in case of call by reference method, an address of the value is passed into the function. And in case of call by value method, changes made inside the function is limited to the function only. Whatever we do the changes in the function will be reflected inside the function only, and the values of the actual parameter do not change by changing the formal parameter. Means we are, whatever changes we are making in formal parameter, and the actual parameter are different. They are allocated different spaces, memory spaces. But see here, in case of call by reference method, the changes made inside the function validate outside the function also. The value of the actual parameter do change by changing the formal parameter. Here, whatever changes we make inside the formal parameter will be reflected in the actual parameter also. Why? Because the memory locations of actual and formal parameter are same. That is the same point written here in the third point. Actual and formal arguments are created at a different memory location in case of call by value, but in case of call by reference, actual and formal arguments are created at same memory location. Okay, let us see the examples. Suppose, and I have shown you the call by value method. This one was the example for call by value method. When you, this is the actual parameter, this is the formal parameter, and when we are passing this call by value method, they both are allocated with different memory spaces. B is allocated different memory space, A will be given different memory space. So when we are making changes inside this function, A we are updating with A plus 1 and then we are printing the value of A, it will give us the value of A, that is 4. It will print 4. But when we are writing this statement printf B, so B was the actual parameter. We have updated this parameter, but when we print this, we will find that the value of B will remain 3. So this is the value, this is the uh, example of call by value method. We'll see one more example. So let's take the value, let's see the function for swapping two variables. Swap int A and int B. So suppose we do this by call by value method. So whatever be the code we write here and inside the main program, we create two variables int x and y, and we want to take these values as input from the user, enter x and y. Then we will write scanf %d %d x comma y. After that, we want to swap the values stored in x and y. Suppose user enters x equal to 3 and y equal to 5. What we want to swap them, means after swapping, x will have the value 5 and y will have the value 3. Means we have to exchange their values. So we want to do this with the help of this function. So we will pass this x and y. And after that, we will print the value of x and y. X equal to %d x and enter y equal to %d y. And then we are summing out. See, this is your actual parameter. And we are passing by pass by value or call by value method. Okay. So here in the code, we are using the code for exchanging the two variables. It is int, we take a temporary variable and we write temp equal to a, then a equal to b and b equal to temp. Now see what happens. When we run this program, you will find that the swap is doing, swap function code is okay, but the changes done here is done inside the function only, and this since it is a new copy, it will be allocated different memory locations. So whatever changes done is inside is done in the copy of that is A and B. It will not be reflected in your calling program inside the main. So first let me explain what is pointers, because we need use pointers to store the address. So we can say that it is a variable. It is a variable which stores the address of another variable, which stores the address of another variable. Means it can store the address. Okay. So generally, the syntax of the pointer's declaration is data type star pointer name, ptr name. In this way, we create the pointer. So we write the data type of the same data type whose address we want to store in this pointer. Okay, this is the pointer name, and this is the symbol we use for pointer. So what it will store? It will store the address of another variable of this data type which we declare. If I write int pointer p, so it means p is a pointer which can store the address of an integer variable. So we can suppose if I make a variable int a equal to 5, then I can store the address of a in p. For storing that, we use this ampersand operator for address and write ampersand a. So the address of a will be stored in p. And to find the value of this a, we can use this p using indirection operator. Using indirection operator, when we want to access the value stored in a with the help of pointer, we need to use indirection operator, that is star also, that is also called star. That in that case, we use this star to access the value stored in this. Suppose if I write star p, so it will give you the value stored in the a. You can understand this way that p means the address of a, and when I put star before p, it means we are able to access the value stored in a. If I write simply p, it means it will give you the address of a. And if I add this star above this, it means we are able to access the value of a. So see, since suppose a is this and it is stored at some memory location, suppose 2040. And this is the value of a is 5. Okay. So when I say P means we are standing here. And if I write star P means we can look the value of A. Okay. So now this is the little bit introduction about pointer. We'll discuss about pointers more later on. So it is required to use here in call by reference method. That is why I have discussed this is what is this pointer. So we will use this pointer to store the address. In case of call by reference method, we pass the address of that variable and that will be stored in the formal parameters. So that is why the actual and the formal parameters are same in case of call by reference method. So that is the all about the introduction to pointer. So when we write x equal to %dx and y equal to %dy, the old value of x and y will be printed. This will print only 3 and 5. But we wanted to x should be 5 and y should be 3. That doesn't happen because the value passed was call by value method. Now see the same thing we will do with the help of call by reference method. So what we have to do, we have to pass the pointer here. So for that we write we pass 2 pointers. This is, we are writing the prototype. Or we can just start here the function also. So let me write the function down, or let me write here only. Suppose I'm writing int pointer A, int pointer B, and then int temp equal to whatever we do, we'll write with the help of pointer only. So let us discuss something about pointer. What is this pointer? To pointer B and pointer B equal to temp. Then here also print the value of A is %D and value of B is %D. A comma B, and then close the bracket. Now write the main program. We'll write the inside the main program void main. Let us take the values from the user also, you can take, or you just pass the, let us take the X and Y only. It's equal to 10 and Y equal to 20. We can write in different statements also. X and 10 and Y equal to 20. And then we are calling swap address will pass here. We will not write directly X. We will write address of X and address of Y. And then we will print the value of X and Y. Value of X is %D and value of Y equal to %D, and then here X comma Y, and then close it. You can check by writing the printf value of X and Y, same thing here. So here when it is printing, it will print 10 and 20, but in this line it will print 20 and 10. Why? Because we are passing the address, means we are passing the reference. In this case, when we pass the reference, the changes done will be at the same memory location. We are not creating any new variable, or a copy is not created. In that situation, the changes done will be reflected here. So this is the advantage of your call by reference method. So let us see its example by running on the system. So see, this is the code for swapping the two variables value. So this function is using call by value method. So I am showing you that when we are passing this values as call by value method, the result, the changes made in the function, inside the function, it will show the difference. It will show the changes. But in the calling program, in the main program, the changes done will not be shown. See here, the before swapping it is x and y, and inside the swapping we have written the same code for swapping, and then we are printing the value of this variable passed inside the function. You will see that the changes done will be shown. And again, in the main program, we are printing the value of x and y, which was passed as call by value method. Now we'll see its output. So let me, now let's run this program, compile it. Okay, it's okay. Now run it. See, before swapping the values in main is x and y is 10 and 20. And after swapping, inside the function, a value and b value has been changed. Earlier, the x value is copied in a and y's value is copied in b. So it is storing at the different memory location, a and b. And we are swapping the value of this a and b. So it becomes 20 and 10. It is showing inside the function, it is showing correct. And again in the main, after swapping in main, we are printing the value of x and y. So we are getting the previous value of x and y, that is 10 and 20. So this was the call by value method. That's why the result is not reflected. See, in here, this one is call by reference method. Here, it is by using this pointer, we are able to store the address of that variable passed using the reference method. So in this, see here, we are passing the address. This is the main difference here. We are passing the address of x and y. So here when we print the value of x and y, it is before swapping, it is 10 and 20, okay? And we are calling this swap here. So swap, inside the swap, we are using this code. We are taking the value of pointer a, means the value stored in this a variable. It will store the address of x because we are passing the address of x. So it is mapped with x, and b is mapped with y. So b will store the address of y and a will store the address of x. And with using indirection operator here, pointer a, we are able to access the value of x, and we are storing it in a temporary variable temp. And then we are writing pointer b equal to pointer a, means the value stored in b will be copied in pointer a, and temp is storing the value stored in a earlier value. So it will store that value inside the b. And now after swapping, we can find the values changed is reflected in the function. That is okay. And when we print this value after swapping in main also, we will find the swapped value. So let us run this program. Let us run this program. Compile first and then run it. So we'll see. In the main program, before swapping, it was 10 and 20 x and y. And after swapping values in function, inside the function 20 and 10, that was showing in that also call by value method, same thing here. And after swapping, values in main is x and to x20 and y10. So we can see that using this call by reference method, we are able to see the changes in the main program also. So that's all for today. Thank you. Thanks for watching.